Hi boys and girls. All right, we're gonna do an experiment to talk about inertia. You just watched the video about inertia and you took hopefully a little bit of notes. All right, so I have a tablecloth here, and on this tablecloth, on my table, you see that I have a paper plate and I also have a plastic cup. Now, we know that inertia is the tendency of objects to keep doing what they're already doing. Just like Rafi wants to continue staying on my table. All right, so objects want to keep doing what they're doing. An object that's at rest, like the plates here and the cup on my table, they want to stay at rest and keep doing what they're doing. And they will stay there until a force is applied. Like, we really kind of already know this. All right, so an object in motion is going to want to continue being in motion until you apply a force. Now here's the thing, what I'm going to do to demonstrate inertia, the idea that objects want to keep doing what they're doing, is I'm going to pull this tablecloth out from underneath this paper cup and also this plastic cup. And now if you watched the last video, you would have also heard that something with more mass also has more inertia, meaning something that is heavier will want to continue to do something and resist the change even more than something that is light. Now, this paper plate and this paper cup are very, very light, right? So what do you think will happen when I pull the tablecloth out from under them? Will they have enough mass and therefore enough inertia to stay where they are? All right, let's try it out. All right. Pull it, and the idea here is that you have to pull it really, really fast. And all I have is a giant tablecloth, all right? But we're gonna make it work, all right? Now, do you think that there's enough mass and therefore enough inertia for the paper and the plastic cup to stay where they are? All right? Nick, what do you think? No, Nick doesn't think so. What do you guys think, boys and girls? All right, let's see. I'm gonna pull it really fast. You ready? And go. Did they stay where they are? No, they would not. All right, so let's set this up again, y'all. This time, I'm gonna set it up, and I'm going to get some of the Godfrey's very, very, very fancy and precious and also a little bit more massive dishes to put on. All right, let's get a blue plate, and let's get a really big mug. All right, I'm gonna put them on the table. All right, now remember, we said that something more massive would have more inertia. Now, do you think that when I pull the tablecloth this time, that the cup and the plate will fly off? Am I going to break it? Or do you think that there will be enough mass that it will stay in place even when I apply force to the tablecloth? Right? Because I'm not going to apply force to the plate and I'm not going to apply force to the cup. I'm going to pull the tablecloth out, so I'm only applying force to the tablecloth. Will it stay? Let's see. Nick, what do you think? Do you think it will stay in place? All right, let's do it. Ah! Not if there's a cat. Remember, inertia, the tendency to keep doing what you're already doing. And this cat wants to be on the table. Okay. All right, y'all, let's see, am I gonna break the precious heirlooms from the Godfrey house? Okay, what do you think, Nick? Am I gonna break them? All right, let's do it. What if I can't pull it fast enough? Ah! Okay, let's go. Ah! I got scared. Let me try it one more time, boys and girls.
You're cleaning that up.
Of course I'm cleaning that up.
You know you can cut the video.
I
and
know,
cut that out.
honey, I know.
Are
But
you
it'd be
going
funnier if it's there. Okay.
Yeah, but it didn't prove the point.
It doesn't matter whether it proves the point. I didn't pull it fast enough. Okay. All right, now let's try again. I always get nervous, y'all. All right, let's see if this stays put. I'm gonna pull faster and harder this time. Apply more force just to the tablecloth. And woo! It had enough mass and therefore enough inertia to stay on the table. Inertia.